student, in my previous video I introduced complex numbers and I explained how the complex numbers are represented, and also I derived the imaginary unit I whose value is square root of minus 1. We derived the value for I which is square root of minus 1. Now in this video we are going to find out the various powers of the imaginary unit I. Powers of imaginary unit I. Powers of imaginary unit I. Now in this video I am going to explain the various powers of I. We know that I is equal to square root of minus 1. I is equal to square root of minus 1. This is nothing but I power 1. It is I itself, it is equal to square root of minus 1. Next, I square. It is square root of minus 1 square, because I square is the square root of minus 1, minus 1 square. On squaring square root, it vanishes, it will gives you only minus 1. So I square is minus 1. I square is minus 1. And I cube is I square into I, which is equal to I square is minus 1 into I, that is equal to minus I. I cube is minus I. Then I power 4. I power 4, I can write it as I square into I square. This is minus 1 into minus 1, which is equal to 1. Minus and minus plus 1, because I square is minus 1. I square is minus 1. So minus 1 to minus plus 1, therefore I power 4 is 1. So we find out the values for I power 1 is I square is minus 1, I cube is minus I, and I power 4 is equal to 1. The I power values are repeatedly gives you these 4 values only again and again. Because I power 5, see I power 5 is I power 4 into I. I power 4, 1 into I is equal to I itself. So I power 5 is again I. I power 6 is I power 5 into I. I power 5 is I, again I. It is I square. So I power 6 is again I square, which is minus 1. I power 7 is I power 6 into I power 6 is I square into I, which is equal to I cube. So I power 7 is I cube. I power 8 is I power 4, the whole square we can write. I power 8 is I power 4, the square. I power 4 is 1. 1 square is 1. Again I power 4 is 1. I power 8 is again I power 4 only, that is 1. So like that, I power 5 is I power 6 is I square, I power 7 is again I cube, I power 8 is again I power 4, which is equal to 1. The powers of the imaginary unit I is 1 to 4, again these values is repeated again 5 to 8, and that is again 9 to 12, and so on. Every 4 multiples are equally implies the same values. So that from this, I power of multiples of 4 are always 1. I can say I power 4, I power 8, I power 12, and so on, etc. I power 100. It is also 1 because powers of I, if the powers of I are multiples of 4, which gives the value is only 1. So all the multiples of our 4 are 1. From this, I came to a conclusion. The general idea of the integral power of I is, I am going to define now. See, I power 5 is I power 6 is I square, I power 7 is I cube, I power 8 is again I power 4 only. Like that, we define the values. From this, I can define for any integer n, for any integer n, I power n has only 4 values. Only 4 values. They correspond to the values. They correspond to the value of n. They corresponds to n when n is divided by 4. Leave the remainder. Leave the remainder. Zero, 1, 2, and 3. This is the definition for the power of I. For any n, I power n has only 4 values. Only 4 values. I power n has only 4 values. For n, those values correspond to n when n is divided by 4 or divisible by 4. When n is divided by 4, leave the remainders 0, 1, 2, and 3 only. So from this, we conclude a general idea of the power of I. From this, I came to a conclusion that the integer n is 4q plus k. The n is defined by 4q plus k. That is 4 multiples of the integer q plus the remainder k. This k has a value between 0 and 4, greater than or equal to 0 or 4, because the k gives a remainder which leaves from 0, 1, 2 and 3, which is less than 4 and equal to 0. That's why the remainder remains. Like that, we can find the powers of I. See, I power n is I power 4q plus k. This is equal to I power 4q into I power k. I can put it like this by product rule. This is I power 4 the whole power q into I power k. I power 4 is 1. 1 power q into I power k. 1 power q is 1. 1 into I power k, which is equal to I power k. The remainder value 0, 1, 2, 3. This is the remainder. It's again I power k only. I power n is I power k only. After finding this, see this? Like that, we can derive the powers of I using this division algorithm. Implies that this is by division algorithm of n. This is 4q plus k. Q is an integer and k remains the value 0 to 4. And n is less than or equal to minus 4. Yes. N is less than or equal to minus 4. N is less than or equal to minus 4 or n is greater than or equal to 4. Minus 4 to plus 4. In this less than or equal to minus 4 left side and then greater than or equal to 4 that right side of the real line. All the values lies between these 4 values only. Like that, the powers of I is defined by using this division algorithm. This is by division algorithm. I can say this value. Now, using this, I am going to solve some problems using this division algorithm. For example, evaluate or find the value of I power 7. This is equal to evaluate I power 7. I power 7 is I power 4 plus 3, we can write it. This is I power 1 into 4. Sorry, 4 into 1, I can get because multiple of 4. So, division algorithm, 4 times of 1 plus 3. See, in the 7, power 7, it has only one time of 4 plus 3. This is I power 4 into I power 3. I power 4 is 1 into I cube. So this is I power 3. So I power 7 is nothing but I power 3, it is minus 7. So I power 7 is minus 7. So using this division algorithm, that is the value of n, we can find I power 7 like this. And this is an example given in your textbook. Example 1, problem number 1. This is given in your textbook as example. Okay. And one more example which is given in your book is, shall I arrange these things? Okay. See, one more example which is given in your book is, find the value of I power 1729 or evaluate I power 1729. So I power 1729 is expressed as I power 1728 plus 1 because it should be split into a multiple of 4 plus the remainder. That remainder should be always between 0 and 3. See, this is I power 1000 4 times. How many 4s are there? 437. Make that 4 7s are 28, 2. 4 4s are 16, 1, 12, 3. 12, 2s are 5. 432. Plus 1. 4 2s are 8, 4 3s are 12, 1, 4 4 7. 17, 20. Okay, good. This is high power of 4 times of multiple of 432 into 4. This is nothing but 1. High power 4 multiple is 1 into high power 1. Or otherwise it can be expressed, once again I can say this is high power 4. High power 4 into 432 into I. I power 1. This is 1 into I. So this is. Therefore I power 1729 is I. By division algorithm, that rule, n is equal to 4q plus the remainder. Like that we can split and we will get I power 1729. It is in your book, it is example given as example 2. I solved 2 problems which are given in my textbooks. Now, using all this idea, I came to a conclusion that how we find out the powers, and I have listed out the results so far we have derived. Okay. Before that, I am going to find out what is the power I power 0. I want to say what is I power 0. What is I power 0? I can immediately say this is 1. How can you say? How can you say this is 1? I power 0 equal to 1. How can you say that? You ask me. In algebra in lower classes, you have studied any base to the power of 0 is 1. On this rule only I can write I power 0 equal to 1. By this rule only I power 0 equal to 1. Anything power, base anything to the power of 0 is 1, it is given in your lower classes, we have studied. Therefore I power 0 is 1. And now I am going to negative powers of I. For example, I power minus 1. How can you find out I power minus 1? This is equal to, how to find I power minus? I power minus 1, I express as 1 by I. How we write this as I power minus 1 is 1 by I? It's also again from my previous algebra knowledge. A power minus m is 1 by a power m. This is also the rule we have studied already. Therefore, a power minus 1 is 1 by a power m. Like using this, I can write I power minus 1 is 1 by I. Therefore, I power minus 1 is 1 by I. To simplify, I multiply by numerator and denominator by I get I by I square. I by I square is minus 1. I divided by minus 1 is minus I. Therefore, I power minus 1 is minus I, which is I. Result you should remember. I power 1 is I, whereas I power minus 1 is minus I. Like that. We are going to see here next one, I power minus 2. I power minus 2. This is, we can split by result. I power minus 1 whole square. We can write as I power minus 1 whole square. I power minus 1 is again, minus I in the whole square. I power minus 1 is minus I. Squaring I, you get I square minus 1, minus and minus plus 1. So I power minus 2, I square is minus 1. And this is, on squaring this minus becomes plus, I square is minus 1. Therefore, I power minus 2 is again minus 1. This is also one result you have to remember, I power minus 2. And then I power minus 3. This is I power minus 1 the whole cube. By same algebra, I power minus 1 the whole cube. I power minus 1 is minus I the whole cube. That is equal to minus 3 times you multiply minus cube is minus. I cube is minus I. Minus and minus plus I. So I power minus 3 is I. It's I power minus 3 I. Finally, I power minus 4. I power minus 4 is I power minus 1 power 4. It is again I power minus 4. I find what is that? I power minus 4 is minus I the whole power. 4 times 1. Minus I power 4 is 1. 1 for minus time of minus 1 time of 4 is plus minus time of 4 plus I power 4 is 1. So I power minus 4 is 1. So I power minus 1 minus I power minus 2 minus 1, I cube, I power minus 3, I power minus 4 is again 1. So after this negative powers of 4, I, these 4 results are repeated again and again. So from this I came to a conclusion. The results you have to remember are, you see, shall I erase all these things? Wait a minute. Shall I erase all these things? Okay. Now the results we have derived so far. Results we studied so far. Results. What is I power 0? 1. and I power 1 I power 2 I square, that means minus 1 I cube minus I power 4 1. Similarly, I power minus 1 minus I power minus 2 minus 1, I power minus 3 I power minus 4 again 1. You should remember these results for solving the problems. We derived these results so far, and you remember these important results you have to remember for solving the problem. Also, for any integer n, then equal to 4q plus k, which is k is equal to 0 but less than 4. You should remember this by division algorithm. This result is also you have to remember. Q is an integer, where Q is an integer. It is also by division algorithm, you remember. This is another result. It's like one you can say, and it is. Further, sum of the values of the powers of I, first 4 powers of I. Third one, I plus I square plus I cube plus I power 4. This is, you remember, as a third result. Okay. Consolidation. So far we have seen this. How? What is this? I power 1 is I, but I square is minus 1, I cube is minus I power 4 is 1. On adding all these things, plus I minus I 0, minus 1 plus 1 0, so total is 0. So sum of all the I values, I square, I cube, I power 4 are, what is? It is 0. It is one more result you should remember for solving the problems. Thank you.